Okay, welcome to those of you attending live and also those of you viewing the recording. Appreciate you taking the time to check this out today. We're really happy to have you. Today we'll be hosting this live tutorial on authoring with ears and following the INCOSE Guidelines and what's new in QV Scribe. And I look forward to getting started. So my name is James Carr. I'm hosting the call today. And on the chat, we have Trevor Bradley from our marketing team. So if you have any questions as we go along, you can just type them into the chat window. You should have a display, depending on what version you're using. You should have a chat at the bottom of the screen there. That will open a chat window that you can keep open on the side and keep track. If you have any questions as we go along, we can address those as we go. So following this call, all of the links that I reference on the call are going to be made available in the form of a PDF. So I can send these slides along. And what you see on the screen there are links to the different resources that we're going to be talking about. Additional resources that aren't listed here are also included in those slides. So if you would like to follow up on anything that you see, just request those slides at the end and we'll get that over to you. Okay, so main topic of discussion today is going to be around ears, which is the easy approach to requirement syntax. So at its core, ears is a set of 6 versatile templates that can be used to express any type of requirement that you're looking to convey. So they use what we say is it gently constrains the natural language. So it takes the freedom of natural language and puts it into a format where you can gain some efficiencies from being consistent in the way that that information is presented. And it's also easier for the people reading it to interpret that. So basically what we can look for with ears is that it'll have a big impact on your requirement writing with very little overhead. And there's also widespread adoption of this approach, the easy approach to requirement syntax across industry, and it's being taught in universities as well in the academic world. So one of the exciting things about our call today, we're going to be going over the new features of QV Scribe. And one of those is a new ears integration of these templates directly into QV Scribe for Teams. So with the enterprise version of our software, you can get a drop-down menu that has each of these templates listed, and then it's just a matter of filling in the blanks. So we're really excited to show that to you as well. Next up, we'll briefly touch on the INCOSE guide for writing requirements. This was actually the topic of our last live tutorial where we focused on the rules for requirement statements. And new with the latest version of QV Scribe, we have about 30 out of the 40 rules for INCOSE integrated directly within QV Scribe. So if you write a requirement that doesn't adhere to that, that'll be indicated by the quality score. And we've also restructured the way that our configurations work so that now these INCOSE guidelines are giving you more specific information. Okay, so what's new in version 2.10 of QV Scribe? So we talked about the INCOSE guidelines compliance. We've also added passive voice detection, incomplete sentence detection, an on-screen display for best practices and tips based on the results that you're getting from your QV Scribe analysis. And we've also added improved consistency results from the term consistency screen. And similarities are now highlighted so that you can see the results side by side. And of course, as I mentioned, that integrated ears templates for the QV Scribe for Teams solution. So in case you're not familiar with QV Scribe, I'll show you quickly what it looks like. So I'll jump over to Word here. And so this is QV Scribe directly integrated within Word. We have the same tool available for Excel, and we have workflows available for different requirements management tools that you're working with. So typically it works as a CSV round trip. You can export your CSV requirements, analyze them in QV Scribe, generate a PDF report, and then return that document once you've made the changes into your requirements management tool that you're using. So this is what it looks like. You'll see the document is live and open here on the left-hand side. I can go through and I have a few requirements selected, which are now showing up on the right-hand side. Each requirement is given a score from 1 to 5 based on the overall quality of that requirement. So that would include the language that's being used according to best practices for requirement writing, but you also have the ability to customize those as well, which we'll get into. So you can tailor these to the individual needs. And again, with that QV Scribe for Teams solution, you're able to push those configurations across all users on your network so that everybody's working on the same page. It can really help to unify your team. So this is the consistency analysis for terms and units, which we'll look at later, and also the similarity analysis with that new workflow that I mentioned earlier, where we now have side by side the two requirements next to each other with what is the same and different within them. So really excited to show you those features, as well as the new EARS templates, which you can see here. I'll show you how that works when we return to that in just a few minutes. So that's what we have on the plate for today. We're looking forward to get started. So I'll start with EARS. So easier approach for requirement syntax. Then it'll jump into actually converting a document that was written without EARS and converting that over to EARS, so you can see how you can approach that if you decide to convert some of your kind of core documents over to this approach, if you decide to adopt it. And then I will also talk about making the adoption of EARS and INCOSE even easier using that QV Scribe tool that I showed you a moment ago. So what is EARS? According to the dictionary, EARS is an organ for hearing. Okay, yeah, we know that. But there's a cool thing on here that I found when I was looking this up, which is, the way that this can be used to say that somebody is able to recognize, a good sound or what's true or what's something good. And you could say that he has an ear for a good song. So you could say that EARS gives you an ear for good requirement. So once you've learned the system and you've seen that these templates, how they work, it will allow you when you're reading any requirement to immediately see, okay, this could be easier to read because the way that my brain is understanding it once I'm used to working with EARS, you really see how difficult to read most requirement specifications are. So easy approach to requirement syntax, a little bit of backstory on it. On the screen there now is a guy named Mav, and he was working with Rolls-Royce several years ago, back in the mid-2000s. He was with Rolls-Royce. Rolls-Royce, we got Drake there. Not that Rolls-Royce though, it's actually the one in the background. You see it there. Yeah, there we go, Rolls-Royce. So Rolls-Royce, think airplane engines, that division, which is a much larger part of Rolls-Royce, not rebranded BMW. So easy approach to requirement syntax. Mav was working on these with a large team of engineers. So it was really important to note that this approach actually came out of industry. So they were working on their requirements and really needed to find a way to streamline the way that they were being written so that there was consistency across them. So in doing that, you might have read this in the EARS article if you downloaded that, they realized that there was an ongoing trend. Once they started to kind of simplify these requirements down to their core, they realized that there was a pattern that they were following. And they took that pattern, kind of fleshed it out a little bit more and said, okay, we can actually nail any of these requirements down into 5 different categories. And then by combining those, you could say there's a 6th for complex requirements that include more than one of these EARS templates. So it started in industry. It spent some time in academia getting fleshed out. You can actually see there's some research online about the EARS method and some case studies that's been done for that. And then ultimately made its way back into industry. So natural language is at the core of this approach, and there are some alternatives to using natural language. So I'll briefly touch on an article that we have that talks about this, but requirements can develop naturally out of discussions with stakeholders when you're using natural language. That's why we think it's the preferred method to use. And the informality also makes it easy to specify diverse concepts. So if you have that freedom to really express what it is that you're trying to say, it makes a big difference, and it clears up a lot of the ambiguity that can happen by using these different kind of abstract notations and different approaches. So the use of natural language in requirements has 3 common severe problems though. So you look at the benefits that you can express these complex ideas, really reduce ambiguity. But really the flip side of that is, since you have that much freedom, if you're not following some sort of method to make sure that you're communicating clearly, you can end up with these 3 very common and can be very severe problems. So first is ambiguity. You have that freedom. So somebody might be using what they call crutch words sometimes, where you're kind of propping up your idea with some different concepts. It ends up being long and wordy, and at the same time, it's not really saying what it is that you want the system to do. Another problem is inaccuracy. So you can convey loosely what you want to have happen, but you're not really specifying what it is that you want the system to do. And then lastly is inconsistency. So you might not realize that 2 requirements are related to each other. You're writing it in natural language, so they could be hundreds of pages apart in your specification, but are actually in conflict with each other. And those types of errors are really hard to read when you're just reading this in kind of paragraph natural language form. So we have an article about this called The Drawbacks of Using Modeling Languages and Rule Set Checklist and Requirement Specification. And to summarize that, again, there's a link here if you request the slides. It says the main problem with modeling languages is that they cannot be used throughout the entire systems engineering process. So that means it's really good for these functional requirements and the specific level of requirements that we're talking about. But when you get into business requirements or different people that'll be coming in on that discussion, that modeling language won't be understood by everybody involved. So you need to use a different type and then come back to the modeling language for that particular part that you're talking about. So as a result of that, and just that idea that sometimes these modeling languages can be hard to understand, is that 95% of engineering specifications do use some form of natural language. So the vast majority of those are written in plain language. There are some kind of constrained rules that make up about 15% of those. But if that's of interest to you, you can check out that on our website as well. The other article that many of you may have downloaded already is the Easy Approach to Requirement Syntax Definitive Guide. So we've partnered with MAV to put together the authoritative guide on EARS and how that approach should work. So to summarize from that, EARS helps solve these problems that we talked about with ambiguity and vagueness by bringing just enough rigor to the process of writing requirements in natural language. So again, that word, gently constraining those requirements so that you're following a system, but you're still able to use natural language to express those complex ideas. So what are the 5 types? You see at the bottom there, we have complex, which is a mix of any of these different types of requirements, but I'll go through each of these and give examples. But you have ubiquitous requirements, which are true all the time. Event-driven, which is when something happens, how you want the system to respond. State-driven, which is what's happening while the system is in a particular state. Unwanted behavior is actually when something unexpected happens within the system. It's not responding to external factors. That would be more an event to happen. But unwanted behavior is actually like, oh, this sensor fails or this system doesn't work the way it's supposed to. What's the backup? So that would be unwanted behavior. And then optional requirements are if you have a system where sometimes a certain feature will be installed, other times it isn't. The optional requirement makes it clear that that particular instance, when that is or isn't installed, is the situation that you're talking about. So EARS answers the question, okay, how am I going to say this? So you're approaching a new requirements document, you're staring at the screen and you're thinking, okay, I know what I'm trying to convey here. I know what I need. I know it needs to be built, but I'm having a hard time kind of figuring out where to start with it. So applying the EARS approach, what that will do for you is actually remove this level of how am I going to say this? So you identify what type of requirement it is, and then you already have your framework for how this is going to be structured, and you simply fill in the blanks. So if you've ever been staring at the screen like this, not sure if I've conquered writer's block or if I'm just writing nonsense, then EARS can help you with that. So the first example is for a ubiquitous requirement. So the way that this is structured is you just put the system, you're making it clear who or what is responsible for this. In this case, it's a system, so the what, and then what the system shall do in response. So this is different, first and foremost, from a lot of requirements that are written because it's not using passive voice. So it's saying actually what is responsible for accomplishing this instead of just saying what needs to happen. So that makes it more clear what the agent is or what system is being applied for this particular requirement. So the example that we have at the bottom there, if we were building a garage door opener system, you might say the garage door opener shall display the power status. So ubiquitous requirements are actually very rarely used in systems engineering because most of the time the system is responding to whatever state it's in or whatever event is happening around it or what the sensors are picking up. So these complex requirements, very few of them are ubiquitous because most of the time it is when it's in this state, it'll do this. When it's in that state, it will do that, or under a certain circumstance. So ubiquitous example that you have there at the bottom, the garage door opener shall display the power status. That's true for all time. Whenever the system is activated, it will be displaying that in some way. And again, if you've read our 21 tips for writing requirements, you'll notice that this is implementation neutral. It's not saying how that needs to be displayed by saying it's a light or a switch or an indicator or an LCD display. It's the responsibility of the designer to come up with that. So you're just specifying what needs to happen. You need to display the power status. So an event-driven requirement is the next type. When the trigger takes place, when this happens, the system shall, and then the response. So when the open button is pressed, the garage door opener shall open the garage door. Next is state driven. So while in a particular state, the system shall, and then the response that you want. So while the garage door is open, the garage door opener shall turn the light on. Next is unwanted behavior. So if unwanted behavior, whatever that behavior is present, then the system shall and the response. So if the obstruction sensor fails, then the garage door opener shall enter emergency mode. So like I mentioned earlier, the unwanted behavior refers to the system encountering a problem. Use if for that type of unwanted behavior, and use when, which is the event-driven template, for when normal events happen that the system will encounter. Next is the optional requirements. This is when an optional feature is included. So where optional feature is included, then the system shall, and then the response. So in this case, we could say where the keypad isn't installed, then the garage door opener shall require a passcode to open the garage door. So those are the 5 types of EARS templates that we're talking about. And then lastly, we do have the complex model, which is if you need to combine multiple, maybe it's a state and a particular event that happens. So for this example, we've combined a state and a event. So we have while in a certain state, when this trigger happens, then the system will respond in this certain way. So how that might look in an example is while the garage door is closing, when the open button is pressed, the garage door opener shall stop the garage door. So one thing that you'll notice as we go through these templates is that it's all about organizing the information in a logical way. So when I'm reading this, it's laying out exactly when and how this is supposed to happen before it tells me what the system response is. And also you'll notice that the system response is always at the end. So I've read a lot of specifications that actually start with what you want to have happen. So the system shall open and close the door when you hit the button on Tuesdays, Wednesdays, and holidays, and when somebody's in the driveway. So you read a requirement like that, and you're first figuring out what needs to happen, and then later trying to piece together exactly what scenario that's happening in. And then often you have to go back to the start again to figure out what it is that you're supposed to be doing in that scenario. So with the EARS method, you're actually starting with the state that it's in first. So you're saying, okay, when the garage door is closing. So somebody's reading this, they know that this is only for when the door is closing. And then they'll say when the button is pressed. Okay, so the door is closing, somebody presses a button, what needs to happen? Well, in that case, the garage door opener shall stop the garage door. So somebody can read that one time and understand exactly what it means because it's laid out in a really easy to follow logical order. And because you have the freedom of natural language within those kind of brackets or within those slots that you're filling in, it allows you to still express complex thoughts, but it's laid out in a way that's a lot easier to follow. And if you have any questions as we go along, you can type them in the chat window, like I said, and we'll take a couple of breaks along the way to answer those, but we'll also be answering them at the end. So just to kind of visualize what it is that I was just talking about, we see on the screen here, everything that's highlighted in green is the system response. So when you're reading a specification, all those things that are highlighted in green, you know where to look for them. And then all of the preconditions that need to be in place for that thing to happen are at the beginning. And at the very start, we actually have the indicator of what type of requirement this is. So that's probably the biggest thing that's a little bit, takes some getting used to when you're writing in EARS, is that, for example, any of these words could be used for different types, but by specifying, for example, the use of the word if is always for unwanted behavior. If you're applying EARS, then by using that word if, you're making it clear to the reader that this is an unwanted behavior that you're dealing with. When you use the word when, it's specifically for event-driven, while is specifically for state-driven, and then optional features, even though the sentences can sound a little bit odd sometimes, using that word where to define what's going to happen when there's an optional feature present makes it that much clearer when somebody's reading it. So once everybody gets used to using EARS, they know exactly what they're reading as you go along. And then you'll see the complex one at the bottom there has the 2 indicators for what is being applied there with EARS. And you can see each of those highlighted individually. So now we're going to take a few minutes to convert a requirements document to EARS. So the one that we have here is actually a real document for you can see miles per hour in there. So this is an American car manufacturer, public document that they've made available for their full speed range adaptive cruise control. So you might know this as radar-based cruise control or advanced cruise control. But this is where you have the speed is set by the driver, but it's also using a combination of radars, cameras, or sensors, not LiDAR if you're Tesla, but you have those radars on the front that are measuring the distance between you and the vehicle in front of you to determine what speed it's going so that it can keep you a set distance behind. So this really loose specification of about 20 requirements is just walking through what this system should do and how it should behave. So you'll see this is what it looked like in QV Scribe. And before we dive in, I just wanted to point out, this is the original score that it gave. You can see over on the right-hand side, I can get a really good indication of just out of the box with the standard configuration for QV Scribe. This achieved an overall score of 3 out of 5, and you can see some of them scored 1. We had a few 2s, 3s. So that presents the, makes it clear to the reader the level of risk that's represented with each of those requirements. So you can quickly review them and take the ones that are the highest risk and deal with those first. So I went through and spent about 6 minutes working with this document. I actually have a sped up version of the video. If you'd like that, you can send me an email. But I spent 6 minutes working with this document and converted all of those scores that averaged out to a 3 out of 5 and had them score a 5 out of 5 using QV Scribe. So if you'd like to see that video, send me an email. I can send you the link to it. But this is actually outside of EARS. So you can apply the EARS templates first and then apply QV Scribe to it. But even if you're not using EARS, this type of feedback can be helpful, again, referring to those INCOSE standards that we talked about. That can be really helpful in cleaning up your document, reducing risk, and again, making them that much easier to read. So, we got a question before we dive in here.
So one question from Joseph Smith. Does QV Scribe automatically prioritize those results?
Yes, it does. Thank you, Joseph. So the question was, does QV Scribe automatically prioritize these results for you? So you can actually, the way it's viewed in this window right now is the highest score is at the bottom and the lowest score is at the top. So you can deal with those first. The default view when you run the analysis is that it will show up in the same order that it's found in the document, but then you can sort it according to issue if you want to deal with the issues with imperatives first, or you want to deal with vague language, those things. You can deal with them one at a time by issue using that drop down that you have up above. But there's a couple of different ways that you can work with those. It's listed here by order of priority based on risk level, but you can sort them by the way that they're in the document, or some different ways. It works just like a spreadsheet. You can click those columns at the top to sort them in different ways. All right, so let's dive into this document. So I've selected 6 requirements from this document, and we'll look at each of them one at a time and convert them to EARS. So the first one is the following distance will be computed in seconds behind the forward vehicle. So it's talking about that measurement. Depending what speed you're going, that's going to influence how far back your car should tail. If you're going faster, then you need to be further back than if you were closer. So the car will automatically make those adjustments, and it's saying that it's going to measure that distance actually in seconds. So when the car's at a certain point on the road and your car's at a certain point on the road, how many seconds will it be until you reach the point that the car is currently at? So this is a ubiquitous requirement because it's just saying something that the system will do, and this is true of all time. It's always going to be calculating that distance in seconds. So we need to format this by the system shall and then the system response. So let's identify these in the document. We have the following distance, and we're talking about will be computed in seconds behind the forward vehicle. And this is written in passive voice. So you'll see it's just saying will be computed, but it's not making it clear who or what is responsible for that. So the system in this case is actually the full speed range adaptive cruise control. So you could have a glossary for this document that defines what that means. And then you can simply use the FSRACC full speed range adaptive cruise control system shall, and then list in that system response. So we can reformat this to the FSRACC system shall compute the following distance in seconds. So it's taken that longer thought and conveyed it in that kind of organized, structured system that we laid out. And if you did think it was helpful to add that comment about the example, you could add that below as a comment, but make it clear that it's separate from the requirement itself, because when you get into later stages where you're converting that into a testability matrix and you're actually going through to making sure that the system is doing what you intended it to do, having that broken out separately is really helpful at that point so that the person who's doing those tests can quickly check it out. So the next one is event-driven. So when there's a trigger, the system shall system response. So we're actually going to go into QV Scribe for that one. So I'll show you in the actual Word document here. So here's our document. The first one that we did is already in there. So the second one is if the car in front of the subject car slows down, then the system will adjust to a lower speed. So if I wanted to use the EARS templates in QV Scribe, I could identify first that this is an event-driven requirement that we're talking about. So up here in the QV Scribe ribbon within Word, I have the place requirement template. I click that link, and you'll see right here those 6 templates, along with the description of when they're to be used and what that will look like when you click it in. So we're looking for the event-driven requirement, so I click that. And you'll see now the requirement is already filled out and it's already been added to QV Scribe over on the right-hand side. So when, and we look for what the trigger is in this situation. So if we could break this down, we might say, whoops, when. We'll call that one the lead car, and we could add that to the description as well. So when the lead car, the glossary I mean, when the lead car slows down, the full speed range adaptive cruise control system shall be in the imperative, and the system response here would be adjust to the lower speed. So that's it. I've converted that requirement to ears. So now, since I have QV Scribe open, I can run the analysis on it. So I can reanalyze all the requirements now. And that one that we have highlighted here will actually show that this is an ears compatible requirement. And this actually works whether you use the ears template to input it or not. It's actually picking up on the ears patterns and identifying which one is being used. So if you're writing without using the templates, you're just writing using ears, then those will show up as well. So it's identifying each of those systems. And then we have a 5 out of 5 score. So there's no quality warnings or quality score issues with that one. We do have a question.
So a question from John, does shall convey the same meaning as will?
Yes, so that's a great question. The question is, does shall convey the same meaning as will? What's important here is that you're using that imperative statement consistently throughout your document. So there is a possibility that if you're talking about an optional feature, you might use the word should, or for a possibility or an allowance, you might use the word may. If those are being used in a controlled way, then you can actually add those to the list of acceptable imperatives within QV Scribe. If you'll see here up on the in the ribbon, I can select this configuration tab. So with QV Scribe for Teams, this is under the control of anybody that has administrative privileges, which you'd have control over. And you can go in and actually change each of these different word libraries. So we have here the list of imperatives. So for this document right now, we have the word shall, must, is required to, are applicable, are to, and responsible for. What will typically happen when you're writing a document in this way, if you're using one imperative consistently, you'll want to remove those other ones from the list so that the imperative that you're using is consistent throughout. So in this case, they were using must for this document for the most part. I prefer to use shall, so I'm converting them over to shall, but you can use either one, whichever your company prefers. And if you want to remove the other ones from the list, you can actually just click here in QV Scribe remove. It won't delete them permanently, it just moves them to this list of example words that you can easily add them back in. But you can also add your own words as well. So if there's another system that you're following, or maybe your company has always done it a certain way, you can add those words to that list as well. And a follow-up question?
Another question from Arjun. What does the preconditions FRACC is engaged mean? We did not specify that.
Okay. Let's see. We'll discard the changes. So when the system is engaged, I don't think we've done that one yet. So the one we just did was when the lead car slows, the FSRACC system shall adjust to the lower speed. That one, when the system is engaged, we're going to cover that one next. So we'll do that one right now. And for that, we will actually jump back to PowerPoint here. So we'll show you that one right now. So here it is. If the so event-driven requirement that we just looked at, there it is laid out the same way. This one is actually pretty close to ears starting out with, so it just needed a couple of adjustments to conform with the way that we're writing it. So the next one is the state-driven requirement. So it says the system will have indicator lights for when the system is activated, engaged, as well as the status of the cruise control. So if I look at this, it's talking about a particular state. So when something is happening, this is what I want the system to do in response. So if we could highlight this, the things that are highlighted in blue are sort of those states that's describing when the system is activated and engaged, and then the status of the system. So you might have seen this in your own car. You have one indicator that shows that your cruise control is on. So it's using a little bit of power. It's measuring your current speed so that at any time you can hit that button to activate the cruise control. And typically when you activate the cruise control, another light will come on to show that it's engaged. So this is seems to be talking about something like that. So if we were to phrase this according to ears, we would have we're talking about these different modes that it's in. So we could, again, specify these modes in a glossary, but we'll say while the full speed range adaptive cruise control is on standby, the full speed range adaptive cruise control system shall display the standby status on the dashboard. So this could actually be broken into two separate requirements. You'll see that there's two sections up here that are in green and two that are in blue. So that tells me we're probably talking about two separate requirements. So if you were to add a second one, you might also say while FSRACC is engaged, the system shall display the engaged status on the dashboard. So in another place, you could specify what that icon, later on, they'd specify what that icon would look like, how exactly it would be displayed. But the point here is that you're conveying that this status is being displayed to the user. So next is unwanted behavior. And for that, we're also going to dive back into QVScribe. So I'll jump over and show you how that template can be used. So we have down below here, unwanted behavior. So for this one, we're just going to convert it to ears first without worrying about the other problems that are there within this requirement. So let's just use the template to do that first. So we're dealing with unwanted behavior right now. So if a component of the system fails, so let's pull up that unwanted behavior and we'll type that in. So again, it starts with if, because this is for unwanted behavior. So I'll just write in what we have above. If any component of the system fails, and then we have that's inputted automatically, and we're talking about which system. So again, that's the full speed range adaptive cruise control system. And we're using the imperative shall, so we fill that in the blank. And then what is the system response? So I look up here, I actually see that it's the system will notify the driver and disengage immediately. Okay, so now that's been entered. We go on fails here. There we go. So this is, again, it's automatically entered in QVScribe. So I can analyze this requirement now. Go back up here. So we'll reanalyze the document. And now this new requirement is listed here. Let's go back here. Oh, you have a question?
Just a question on that requirement. Should that be two requirements with both notify and disengage?
Yes, it shall. So we are going to look at that right now. So first, I was just taking the way that it was written and putting it into ears. That's a great question because it is asking for two different system responses. Now, according to ears, if you look at the definitive guide, it does say that you can have two different responses as long as it's consistent that those two things are always happening together. Ears would dictate that you could include both of those within the same. The INCOSE Guide for Requirements, this is the one area that I've seen where they seem to convey something a little bit different, where the INCOSE Guide would say each separate response should get its own line. So that would be up to you, the writer, to decide, okay, is this still going to be testable if those two things are separate? In this case, I probably would break them up because you want to first test that, yes, it's going to disengage, and then also test that it's going to notify the driver. So let's add this back in, and we'll analyze those requirements. So we see now that this requirement scores 3 out of 5. So this is according to the INCOSE guidelines now. So I can actually open up this requirement over on the right-hand side. We have that ears feedback as well. But at the top, you see that we've been given a quality score. So that would be the 3 out of 5 because it contains non-specific temporal words. And we've also identified that it contains a universal quantifier. So the difference between these two is that the quality score is actually telling you why it got this score of 3 out of 5. The quality warning is this indicator with the triangle here, the warning sign. And this isn't actually taking off any marks. It's just bringing it to your attention because there's a few examples of times where certain words that are being used could be okay in context, don't necessarily impact the readability of the document. But if you're using that word incorrectly, it can really cause problems for the scope and scale of what you're looking to do. So I can click on these issues and actually see it highlighted on the document. It also shows me the word over here on the right that is causing the problem. So first it's saying if any component of the system fails, and I should actually add in what they had there as well, because this is actually a little bit worse than I communicated. So the controller, radar, etc. If I could spell radar, and then we can just reanalyze this selected requirement. And now we'll see that other issue. So this has been downgraded to a 2 out of 5. I had forgotten to include those, the part that they had in parentheses there. So well, now being highlighted again, the quality warning, we'll look at that first. So the reason that any is being highlighted is because you're saying any component of the system, but it's not specifying what components are included in that. So sometimes any is okay. If you're building a house and you say the house shall be free of any leaks, that's right, because you don't want the roof to leak at all. But in cases like this, it may not be clear exactly which components are included. So it's bringing that to your attention. Now, when you use a word like etc., that is a problem because that is actually saying explicitly that there are more things that should be included on this list that you're not listing. So you could either reference an external list to say, these are all of the systems that apply. If it's a shorter list, you could list them out. But what I would do with this requirement is actually list each of these separately, because you're actually saying, okay, when the controller fails, this is what I want to have happen. If the radar fails, this is what I want to have happen. So that is the first issue that we would need to deal with this requirement. And then secondly is the use of non-specific temporal words, as INCOSE would say. So the word immediately is not clear. So at this level of specification, we're probably not getting into kind of that non-functional requirement where you're saying how and when or specifying what is required for that. So you could remove that, but if you did want to specify, that you're saying how fast this needs to happen, instead of using the word immediately, you should actually put in how quickly that needs to happen to meet the stakeholder needs at this particular level. So we could rewrite this again according to the EARS and INCOSE standards. So if any component of the system fails, so let's change this up. We'll start again from scratch here. Why not? So we'll choose the unwanted behavior and we'll write this in. So what's the trigger in this case? So we want to isolate each of these conditions that we're talking about. So let's call it the radar. So first we'll say if the radar fails, then the full speed range adaptive cruise control system, and the imperative again is shall. So this is making sure that you're following that structure each time that you write, and you don't have to reference another document or recopying and pasting. It just happens all directly within the tool automatically, and then you write in that system response. So we'll leave it at notify the driver and disengage immediately. We'll change that to disengage within 0.2 seconds, so or 0.2 seconds. So according to the EARS method, if you read the definitive guide, this would actually be okay because these two things are always going together. INCOSE would probably encourage you to split those into separate requirements, but we'll leave them together for now, and we'll just reanalyze this as it is. Requirement. So we'll reanalyze the whole set here. And now we have this separate requirement down below that's received a score of 5 out of 5. So again, it's going to lay out the different parts of the EARS template, but the requirement itself, you see, gets a score of 5 out of 5, and there's no quality warning. So I can now move on to the next requirement. So that's how you can use EARS and the INCOSE guide side by side. First convert it to EARS, or preferably if you're working on a new document, write using EARS in the first place. And then it's just a matter of running through to make sure that the words that you've chosen are acceptable for this particular document. So I'll go back into the configuration really quick and show you what that looks like. So when I bring this up, here are my list of negative imperatives, of vague words, and this is the default list that comes kind of out of the box with QB Scribe. But these can be customized, and you can save different configurations that are available for different projects across your team so that each of these can be edited individually. So next up here, we're going to show the other types of analysis with QB Scribe. So this is the quality analysis. We have the other requirements already typed in here. So let's insert, we'll do the optional one first, I guess. So one of the requirements listed here just said pre-collision system overrides the full speed range adaptive cruise control. So this could be an optional feature. So let's put it in that way. So the optional feature which feature is included that we're talking about, that would be a pre-collision, if I could spell, which I can't. There we go. Pre-collision system. So we'll add that to the glossary as well. So where pre-collision system would be, we'll say enabled here. So when that feature is enabled, then the full speed range adaptive cruise control system shall, and what's the response that we want here? So what it's really saying, you could write this into the specification for the pre-collision system, but since we're talking about the full speed range adaptive cruise control system right now, we'll talk about it from that perspective. So you might say that the system would yield to any inputs or responses from that pre-collision system. Okay, so now we have that one entered. And so now we have a set of requirements here, not the full list that we were dealing with earlier, but we can run the analysis on these requirements that are included. And we'll view the analysis over here on the right-hand side. So this is that one that we had mentioned earlier. Maybe I'll just take that out. So if there is one that you want to exclude, you can actually hit the X button right here. So this one's now repeated twice because we reworded it. So I can go and click the X here, and that will remove the requirement from the list. So now we're just dealing with those, the set that we had been working with to convert to ears. So now that that's been done, these all just achieve a score of 5 out of 5. So we can move on to the consistency analysis, and we'll just reanalyze this since we made some changes. So what this is doing, the consistency is looking at the units and the terms that are used throughout the document and automatically populating lists of those things here on your screen. So you'll see here that we're talking about the accelerator in some places, the radar, the standby mode, the dashboard, features, systems. So these are all being listed for you automatically, so you can make sure that those are being used consistently. So if you're talking about the driver at one point in the document and the user somewhere else, having those in list form, this is where the natural language processing comes in QV Scribe. It's pulling those out for you and showing them to you. And you can actually look at them in context as well. So I can click on this and see where that word is being used. I can see where it's used elsewhere in the document to make sure that that's consistent. And then for the units, the only unit that we have listed here in this document so far is seconds. You'll see that the comment here is actually being excluded from the analysis. So that's another feature of QV Scribe. You can specify if you want any particular words to be excluded or any phrases to be excluded. So it's called an exclusion prefix. So we have the word comment excluded right now. So it's only looking at the requirement itself for this analysis. Anything that comes after the word comment is being excluded. So if I wanted to include the whole requirement, I can remove that from the list or just remove the word comment if I wanted to have that included. So if I reanalyze now that I've made that change, you'll see that the whole requirement is now being analyzed, and I'm seeing that miles per hour is present there, along with the seconds, and feet are being mentioned there as well. So I can look at each of those in context. So one thing to note about this is that actually we have feet and miles per hour side by side, and there's a filter here to detect this. So if you have a larger document, you can look at what's consistent with the International System of Units and everything that's inconsistent with the International System of Units. So we have miles per hour as being there inconsistent. So that can cause huge problems, especially if you're working on a document with multiple teams, maybe one's in the US, one's in the UK, and you come together and you're using different units. So bringing those to your attention can save a lot of confusion and make sure that those are being translated correctly when you're moving those into the same document. Now, before I forget, I did also want to show you on the QV Scribe side of things here, or on the quality analysis side, that we do have now with the INCOSE rules, it gives the problem phrase, but if I hover over this, it will actually tell me what to do with this particular issue. So you'll see that box right above where it contains vague words. So we're talking about the word about here. If that was part of the actual requirement, that would be a problem. So it's saying to restate the requirement with vague words or as one or more requirement with clear and definitive intent. So it's just giving you that feedback so that if somebody sees that come up and says, okay, vague words, what do I do with that? It's giving a description of how you can correct that problem just by hovering over it. So that's new in this version of QV Scribe. And again, those different issues that are being flagged and those problem phrases are straight out of the INCOSE Guide for Requirements. So it's going to help you adhere to that standard as you go. So we've looked at the terms and units. And what else is new in QV Scribe is this similarity analysis. So when I open similarity, I can see according to a certain threshold how similar my requirements are. If I bring the threshold up to 100, I'll see that I have no requirements that are exactly the same in this small specification. But if I bring the slider down, it will show me right down to 50% how many requirements are at least somewhat similar to each other. So depending on the size of the document that you're working with, that can be really useful in seeing the requirements that are most likely to contain either a contradiction or to be repeating themselves unnecessarily. So I'll put the threshold up a little bit here. We'll look at one as an example, and what's new with this version of QV Scribe, I will make this a little bit bigger here or bring it up. So you'll see that what's highlighted in red is the same between the two, and what's highlighted in green is different. So one is talking about when the system, and actually brought in that complex requirement. I'll choose a different one here. There we go. So everything that's in red is the same. So one is talking about while the full speed range adaptive cruise control is engaged. One will display the system engaged on the dashboard, and the other one is talking about when the accelerator is released, what will happen. So I can look at those side by side, and I'm able to see right away that those are actually, that they're okay. They're not contradicting each other, and they're not talking about the same thing, so it's not redundant. But it's nice to have those side by side, so I'm getting that kind of live feedback as I go. And I can click through the list here and look at each of those requirements. So I'm really quickly able to get that feedback. So one is talking about here when the system is engaged, the other is when it's on standby. It'll show the engaged status. The other will show the engaged, the standby status. So that's a really quick way to make sure that I'm not repeating myself unnecessarily. If there's two that are exactly the same, maybe one, if you're working with an aircraft, one is for the left wing and one is for the right wing, it should specify within that requirement which one it's talking about so that you're clear when you're looking at that requirement in isolation on its own, you know exactly what it's talking about. So that's why the similarity analysis can be really helpful while you're in that review stage of your document, looking at the whole document together as opposed to kind of at that granular level of looking at each requirement individually. So if we jump back into the presentation here, so these are highlights. And again, if you request the slides, you can go through these again later, but these are the examples that we just showed with the different parts of the system being highlighted. So there's the optional requirement. And then the last one that we'll look at is for the complex requirement. So this requirement says when the driver taps the accelerator, the system is temporarily disengaged while the driver accelerates the car. The system will re-engage at the previous set speed when the accelerator is no longer pressed. No longer being pressed, I'm assuming is what they meant to say, but let's look at this. So we'll call this a complex requirement. So we're talking about a state and a trigger, and the system will engage with the system response. So we can highlight the active agents here. We have those triggers are highlighted in pink. The system response is highlighted in green, and then the state is highlighted in blue. So you'll see here that we are talking about two distinctive things. We have green. In this scenario, this is what will happen. And then down below, we have again green, and then what's going to happen or when that needs to happen as well. So let's break this into two requirements. So first, while the system is engaged, when the accelerator is pressed, the system shall yield to the responses from the accelerator. So you're driving along, somebody presses in the accelerator, it's going to respond to the accelerator until it's released. And to say the second part, we'll break that into a separate requirement that you now see. While the system is engaged, again, the system needs to be on for this to happen. So that's the state. When the accelerator is released, the full speed range adaptive cruise control system shall resume the set speed. So then you're specifying those two things. First one is while that's being pressed. The other is what happens after it's released. And both of those are in that state where the system needs to be engaged for that to happen. So that's an example of a complex requirement.
And just one question. Is there a doors integration for ears as they have a requirements in doors and users directly write in doors?
Yeah, so right now the ears integration is directly for Word and Excel. So when you're importing that document, say you're working on one, you can actually take either a Word document or an Excel spreadsheet and export it as an Excel spreadsheet. As you saw on the Word document, it's actually, we've broken out, you mark each requirement to show this is where it begins and ends. So since QV Scribe already has that information, that where the requirement begins and ends, you can export that as an Excel spreadsheet. And there's actually a format in that that's specific for IBM doors. So if you're writing a specification here, I have my requirements over here on the right-hand side. I can click Export Requirements. And then I can choose whether I just want a regular Excel format or if I want that format to be specifically for doors. I click there and export, and that's going to create a CSV file that's already ready to be imported into doors. So that's the current workflow. It's being used, that's how it's being used today, is you're writing requirements within Word or Excel. And then if it's in Excel, it's already in the format that it can go into doors. If you're writing it in Word, we can export it as a CSV, and that's good for any requirements management tool that you're using. And another question?
One more. Any plans for a web integration such as Grammarly?
A web integration, yeah, it's in the works. I don't know if I can say anything more about that. Okay, so how does this all come together? So we're going to wrap up in the next couple of minutes here. So I just wanted to quickly highlight how the easier approach to requirement syntax can help you. So you see on the left-hand side, we have a black and white picture. On the right-hand side, we have what looks like a color picture. But if you look closely at the color picture, you can see these lines going through it. So I can zoom in on that a little bit more. And this is actually the same black and white picture, but overly saturated colored lines have been added to it. And your brain, when you're looking at it, will automatically fill in the differences. So if you go back to that smaller picture again, you look at the yellow shirt and the green shirt, the blue shirts even, and the skin tones, those colors automatically pop, and your brain is able to piece together what this picture is supposed to look like, even though it's just a bunch of colored lines on top of a black and white image. So looking at this, your brain can do all these cool tricks that we don't know. It's able to pick up patterns and it's able to recognize them very quickly and easily. So you've actually been tricked by this before, whether you realize it or not. When you go to the grocery store and your oranges are in those red bags, that's very strategic. The red tint will give the impression that these oranges are actually more vividly orange than they actually are. And when you open it up, you might be surprised by the results, but that's the same principle that we're talking about here. So how does this relate to requirements or natural language? This has been going around for a long time. Again, these tricks that your brains can play, you can just read that sentence. I'll read part of it, or that paragraph, I'll read part of it out loud, but it says, according to research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letter be at the right place. The rest can be a total mess and you can still read it without a problem. This is because the human mind does not read every letter by itself, but the word as a whole. So if we relate this back to our templates, when you're approaching a requirements document, you say, okay, how am I going to say this? EARS is the answer to that because it allows you to structure your sentences in the same way. So you just fill in those gaps and you really get down to the core of what your requirement is trying to express. But the other side of it is that it also answers the question, what am I looking at here? So if your team adopts EARS and you're writing your requirements in this particular format, it allows you to quickly see what is the system response, who is responsible for it, when is it going to happen? And you see all those in real time. So if we look at the document that we just looked at and have each of those different issues highlighted, you can see how easy it is to identify what is going to happen and when those things need to happen. And again, you're reading it in a logical order where before you read what the system response is, you know under what circumstances that is supposed to happen. We can look at each of those kind of one at a time as they go through, and it's all highlighted in the same way. So let's compare that. This is what it looks like when you're using EARS. And if we overlay that with how it was written previously, you can see there's no method here for your brain to pick up on a pattern. So every time you pick up a new requirement, you're reading it, you have to say, okay, what am I looking at here? And you read it through once and then you're like, okay, I think it's saying that under this circumstance, at this time, this is what it needs to do. And so your brain is constantly with every requirement reapproaching that same issue to try to get clarity on what it is that you're trying to convey. Whereas with EARS, it's organized in the same way every time. So the efficiency gains that you can get from writing your requirements in that way are huge. And by using it within QV Scribe, it's a lot easier to get the rest of your team on board with using those the same approach and the same tools because the templates are built right in. So even if they don't understand the full range that EARS can cover, if they can fill out those templates, then they can get on board with using the approach, and then everybody will be in sync and on the same page with that. So it's really important to catch these requirements in the requirements definition stage, because if you get into implementation, the testing, and then once the product is deployed, the amount of time and energy and cost that it takes to fix those mistakes at the later stage grows exponentially as that time goes on. And 100 times is the bare minimum of what could be the cost to repair something that's already been deployed. For these safety critical systems like they were working on at Rolls-Royce, you have really complex systems that are safety critical, and you have large teams that are working on them, usually under really tight time delays. So those types of problems, human life is a factor. We have a lot of customers in oil and gas where that's an issue, customers in medical devices where if you don't get it right and this device that you've created is being implanted in people and there's a problem, the consequences can be severe, both personally and also, of course, for your company as well. So it's really important to define these requirements in a way that are easy to read so that everyone can pick up on them. So again, to recap what's new in QV Scribe, the INCOSE Guidelines compliance, passive voice detection, incomplete sentence detection, the on-screen display of those best practices and tips. We now have improved term consistency results, those similarities being highlighted side by side, and the integrated EARS templates for QV Scribe for Teams. And just to recap what QV Scribe for Teams covers, it gives you that EARS integration. That the QV Scribe for Teams is deployed on your network. QV Scribe doesn't need to communicate with the internet, doesn't need to communicate back with us. It all happens behind your firewalls. So that concurrent licensing, it makes you able to share the seats between different users so everybody can install it and use it as needed. And then custom analysis configurations are available to all users. So that helps keep everybody on the same page, and your company has full control over user management as well. So to recap, we have EARS, the quality analysis, the consistency, and the similarity. And along with QV Scribe, all of our customers have access to a dedicated customer support manager who's responsible for their account. So everybody, if there's an issue that comes up or you want a question about a particular way that a requirement is written, you're always talking to the same person. So they'll get to know you and get to understand your specific needs so that you're not rehashing everything over and over. They'll also provide a onboarding session for each new user that comes on board, and each new release that comes out with QV Scribe, they'll make sure that you're notified. So it's a constant voice to you back and forth between QV Scribe. That's our customer success department. And as mentioned earlier, QV Scribe currently integrates directly with Word and Excel, and we can integrate with a number of different tools by using that CSV round trip. Works really well in JAMA, works with IBM Doors. For your particular application that you're using, I invite you to reach out to us and we can talk about how others are using the tool with your particular system. I do have a question.
Yeah, the question is, can you send out this recording to participants?
Yes, absolutely. So everybody that registered will automatically get a copy of the recording. And then also you can request the slides if you'd like to have all the links to the different things that are in there. So just contact your direct contact here at QRA. If you don't have one, you can send an email to me, james.carr, C-A-R-R, at qracorp.com. And that will also be at the end here. So you can write that down. And so just to recap, the problem is with natural language. So natural language continues to be the best way to communicate these complex requirements to all audience. The freedom of expression that comes with these with this freedom of expression comes the common problems of ambiguity, inaccuracy, and inconsistency. So what you get with EARS is the ability to make your requirements more consistent, concise, and understandable. And then using QV Scribe, the INCOSE rules and EARS templates can make for a 1-2 punch that unites your team and overcomes the most common challenges with requirement specifications. So it's really those two things together. Controlling the way that your sentences are structured is the way that EARS helps. And then QV Scribe can help with all of those, hundreds of different words that can be used in different ways. It will bring to your attention where the way that you've written that requirement might cause problems and bring to your attention how you might fix that to clarify your requirements so that you're not dealing with these kind of high risk issues. So we will jump into questions. So if you do have any final questions, we kind of dealt with them as we went along here, but if there are any additional ones, you can type them in there now. And I'll just recap. So for next steps, you can contact us to request your one-to-one follow-up. So for existing customers that are using QV Scribe, contact your customer success manager if you'd like to know more about QV Scribe for Teams and getting that EARS integration. If you're already using QV Scribe for Teams, we're working with you right now to roll out the new version that has EARS included. So get in touch with your customer success manager about that. And again, if you have a direct contact at QRA, you can reach out to them to request the slides if you'd like to do that. But the good news is, everybody gets a video link. So if you signed up for this, you're going to get an email as soon as that's available here later today. We'll send that in so you can share this with other members of your team and hopefully take that first step towards getting everybody on the same page. So again, this is what the link will look like when you get the PDF. It will have those direct links to these resources and any other resource I mentioned. There will be a clickable link on that page. So feel free to reach out to us if you'd like to request a copy of that as well. All right, we are at the end of our time here, so I will take any quick questions if there's been any more that have come in, Trevor. I know we were handling them as we went across, but we'll just take a couple more moments here if there are any other questions.
Sure. So I have one question so far. Can EARS be applied to non-functional requirements?
Okay, so the question was, can EARS be applied to non-functional requirements? So that is a great question that actually has to do with INCOSE and EARS, which are both specifically written for systems engineering? And the answer is yes. So what you'll find with QV Scribe, with the way it's been written from the beginning, but especially now that we have the INCOSE guidelines built in, is that some of the feedback that you'll be getting on it might not make sense for a non-functional requirement if you're actually describing the kind of criteria and the particular restrictions that will need to be in place for this to be accepted. But you will find that using it for that level of requirements will help you weed out that vague language and make sure that you're not saying that things should be done easily or consistently or effectively or efficiently or any of those kind of buzzwords that people tend to throw in, but we'll actually make sure that the language that you're using is specific for that non-functional requirement as well. All right, so if there's nothing else, I just wanted to thank all of you again for joining us. And if you're watching this live on the recording, you can feel free to reach out to me at the contact information below if you'd like to know more. And you can visit qracorp.com/qvscribe for more info on QV Scribe. So thank you again for joining, and we'll look forward to connecting with you soon. I'll be sending that email out as soon as the video link is available this afternoon, and you can respond to that if you'd like to connect with us again. Thanks again.